I'm Kate Hendry, and I'm an associate professor in the School of Earth Sciences at the University of Bristol. And I'm an oceanographer. I study marine science, specialising in the chemistry of the oceans.
I'm Laurence Publicover. I work in the English department at the University of Bristol. I work principally on 16th and 17th century literature, but my other area, which is I guess the area that I'm working on more and more these days, is oceanic literature and more broadly relations between humans and oceans. So I'm interested in voyages and shipboard culture and that more kind of maritime studies area, but I'm also interested in ideas about the deep ocean and the seabed. And it's the seabed that we're focusing on today. But we thought it might be useful first to kind of set that up by talking about the oceans more broadly, didn't we, Kate? And particularly the kind of environmental pressures that they're under.
Yeah, absolutely. And I can kick off. I mean, it's one of the main reasons that we study the ocean is they play a really key role in climate change. And they also house a huge amount of biodiversity that's really important for society and, for biodiversity's sake as well, I suppose. One of the main reasons that the oceans play a role in climate is that they house a lot of microscopic life, algae, and these algae take up carbon from the atmosphere. They photosynthesize, they lock this carbon up in organic matter. And when these algae die, the cells sink to the sea floor. And that's where the algae, the dead matter, can become buried. So that carbon is sequestered away. We call it sequestration. And it's locked away from the atmosphere. So it's really important. That process is so key in controlling atmospheric carbon dioxide concentrations. And, I suppose that's where the seafloor comes into it, really. What interests you about the space of the deep ocean and the seafloor?
Well, I suppose one of the things that does interest me about it, and that has interested so many authors, poets, playwrights, novelists about the deep sea and the seabed, is precisely that issue of knowledge. It is a site that seems, relative to the rest of the Earth, the biosphere, kind of biome, alien, different. We don't know much about it. It's a hostile environment, and I think a lot of the writing about the deep ocean imagines that going down there is in some way a transgression, that it's a sort of gaining knowledge that we shouldn't have or that we shouldn't be after in the first place. So I think a lot of these, I guess, cultural attitudes towards the ocean that are inscribed in literary texts do feed in quite interesting ways into, legal frameworks, political choices that we make about or in relation to the deep ocean. And sometimes without consciously knowing that. I mean, it's in many cultures across different periods, the deep sea has been seen as this sort of repository of the things that humans don't want, as a wastebasket, essentially. The place to which we commit things that we no longer want, whether they're kind of sin, for example, human sin that is imagined being taken down to the seabed in some Inuit cultures, or chucking nuclear waste down there. And so I think it's very interesting that there is actually a kind of scientific corollary of this process of thought that the ocean does take up our carbon, this carbon that we keep pumping out into the atmosphere, and that it does fall down to the seabed, though of course it can only do so for so long without us sort of damaging that process.
First of all, you're quite right that this is a really sensitive process, and climate change, and well, in particular oceanic warming, can really impact how much of that organic carbon can become buried. It might mean that actually some of it will start being released from the seafloor. But as I was saying, it isn't just carbon, and it's actually lots of other chemicals, some of them good, if you like. So some of them are being nutrients that are also important for life, things like nitrate or phosphate, but also toxic chemicals too. So some of the stuff that we've been throwing in the ocean, the seafloor can actually be our friend and actually can bury some of that away. So things like heavy metals, mercury and arsenic, for example. But we don't really understand those processes, and it could be, again, that actually the sediments can turn on us, if you like, and start releasing some of these things back again.
Yeah, I mean, it seems to be a wider context for this, which some academics in political geography have been particularly good at talking about, is that with the kind of expansion of human influence on the planet, you know, the fact that we just affect things much more than we used to, that the world that we live in and that we're building and interacting with is increasingly high and deep. You know, we're used as a species to living kind of horizontally, but increasingly our world is involved in these high spaces, you know, satellites, skyscrapers, and incredibly deep spaces, mines, communication systems that run along the sea floor. And these geographers point out that we're not really equipped to deal with this, that we kind of don't necessarily think very well along a vertical axis. But in fact, you know, we are involved in it. We get oil and other kind of energy resources from the seabed. Communication systems, the internet connections that we use for the most part don't run through satellites, they run through fiber optic cables in the seabed. Pharmaceutical products come from the seafloor. So in all sorts of ways we are engaged with it, but perhaps not in a way that we've kind of adjusted to as global citizens. And there are even some words in the English language that I think beautifully bring out that relationship between the deep sea and knowledge. So for example, the word fathom, which as a noun, a fathom is a unit of measurement of 6 feet. So it's literally what you can get your arms around. And it's usually used to measure oceanic depth. So you say, you know, the sea is 4 fathoms deep or whatever, that would be 24 feet deep. But of course, now we use fathom as a verb, not only to mean measure depth, but also kind of to understand. So kind of written into our language is this relationship between the seabed and a search for knowledge, and a search that's often unsuccessful, I think, or only partially successful.
And I really like thinking about that, you know, the idea of comprehending the ocean like that. And what I was thinking about when you were saying that is, as an ocean scientist, I like to think that I have a good grasp of what it means, what these depths mean. You know, thinking about doing some research 3,000 meters away, 3,000 meters below the water, looking at the seafloor. And then I sort of think about it, it's like, well, do I really understand that? Is it just I'm used to it? Is that a different thing? And then I sort of start thinking about, you know, the challenges of doing seafloor research, and I think that sort of plays into it too.
I mean, the analogy that I've seen people use a couple of times is trying to understand the seabed by taking, you know, samples from a ship, kind of, you know, however many miles above the surface, is a bit like kind of passing over a city with a hot air balloon, chucking a bucket out the bottom, pulling the bucket up and saying, oh, this is what a city is like. You know, that it's kind of that level of, okay, you get some information, but how are you supposed to piece that information together to get a real picture of what's going on down there?
Absolutely. And, you know, I think the very first expeditions I did at sea, when I was looking at the seafloor in particular, was really like that. You know, we basically put down on wires from the ship heavy, what they're called box scores, but basically heavy metal buckets with jaws at the bottom that close. And they just bring up a big batch of mud. And it's only been much more recently that I've been able to have access to remotely operated vehicles. So these are basically underwater robots that are housed, they house high definition cameras and videos and manipulator arms and sampling devices. And it means that in real time, you can actually look at the seafloor and look at the habitats. And it revolutionizes how you see things. You see things living on the seafloor as they're meant to be. They're not just sort of piles of goo that have ended up in your trawl. So you know, these technological advances are really, you know, what's making this science actually possible and allowing the advances that we can make.
Do you think it matters, Kay? I mean, I guess, you know, if you look at the kind of 20th century of ocean science, or even slightly earlier than that, the kind of obsession with actually going there as a human, you know, getting into a bathyscape or a bathysphere. Does science have to be done like that? Does it make a difference if you're actually sending a human down to the seafloor as opposed to sending a robot down there?
It's an interesting conversation, and something that I've actually been working on recently, thinking about the future of marine science and thinking about, in particular, how we can make marine science net zero into the future. And so can we move away from having these crewed ships and make science entirely autonomous? And one one of the things that comes up time and time again in the conversations is, the impact on the human side of things. And what does it mean for an oceanographer to not go to sea anymore?
I guess, as we move towards thinking about policy and how we should be developing our relationship with the seabed over the next 20 or 30 years as these technologies increase and as resource scarcity becomes more of a thing, or resource thirst, and we try and use the resources of the sea to a greater extent. I mean, it's how do you harness that fascination with the sea that so many people have, and with the deep sea, in a way that's helpful rather than exploitative?
I think an interesting example of where this could have gone well, but could have gone badly in some ways, was a couple of years ago with the Blue Planet television series. One of the episodes, David Attenborough narrated an episode on the deep sea. And it was the first time that footage from the deep sea like this had been broadcast into people's living rooms. And that could have been taken as a tremendous success. But at the same time, it was really put into this narrative of an alien environment, a very different environment. And some have argued that might actually not have been so helpful. It sort of, in a way, emphasized or amplified that difference between the surface and the deep. Whereas in fact, there are actually lots of similarities. It's just another ecosystem, really. So it's an interesting one.
Yeah, because I guess the danger is that if we do treat it as alien, then, to come back to those larger cultural issues, we don't believe that we have interaction with it. We don't believe that we can affect it. And I think that's a larger problem with the oceans that, is inscribed in so much great literature about the oceans, the notion that they are timeless, that they are sublime, and sublimely indifferent to humans. That if anything, the power relationship runs the oceans overwhelm the humans. And of course, to some extent, that is true and remains true, but what it does obscure is that potential anthropogenic change. I suppose it obscures the possibility of anthropogenic change, the fact that the oceans are not timeless, that we have affected their chemistry, their levels, and that we're going to continue to do so. And I guess that we are increasingly involved in this world, partly because of the amount of carbon we're pumping out into the atmosphere, but also in a more kind of precise sense in the work that that scientists like you are doing on the deep ocean. But it's not only scientists down there, is it? It's commerce, it's energy extraction. It's been energy extraction for a while, but more recently there's been, we're getting closer and closer to something that's been mooted for a long time, since the 1970s or so, which is mining the seabed for metals. And I guess what's particularly interesting about that as an activity is how it's bound up in questions to do with climate, but also to do with global equity and justice, the elimination of poverty. It's an intensely complex affair, isn't it? I mean, I almost don't know where we should start.
I know, absolutely. I mean, it's the way to, I guess we could start thinking about it is, that there is an argument, and I'm not saying I particularly follow this argument, but there's an argument that it's almost inevitable that we will have to do this, because if we want to move towards greener technologies, we need the metals for the battery technology and any sort of energy transfer process that you can find in great abundance in these deep sea deposits. And the counter to that is that it isn't necessarily. There are other technologies out there that don't require these metals, and perhaps as well, we can work towards more of a circular economy when it comes to these metals, being efficient with their use, recycling them properly, that we don't necessarily have to go down that road.
And I guess what kind of, puts that knotty issue, as you say, within a kind of specific legal framework is that the area, as it's nicely called, which is the bits of the seabed that are outside national jurisdiction, so outside any state's exclusive economic zone, have been officially kind of designated a global commons by the UN, and more particularly the UN Convention on the Law of the Sea. So the result of that is that any deep sea mining in the area has to be for the benefit of humankind, or mankind as it was expressed at the time. So yeah, I mean, what can it mean to do this for the benefit of humankind? I mean, in a financial sense, how are you going to incentivize the mining? You know, because it's going to be a public-private partnership. So how are you going to incentivize it if all the money is just going to be sort of divided up globally? There are all sorts of questions about equity here that I think, you know, we're not quite ready to address yet, and yet deep sea mining seems to be right on the horizon. You know, I mean, people are estimating that it could go ahead within the next few years. Having said that, I mean, people have been saying that for a few years now, and it still hasn't quite happened. But you know, the argument that we need the metals to transition to a green economy is a powerful argument. And you know, the way that this is usually framed by those who support deep sea mining is, well, we need to get the metals from somewhere, because at the moment we don't have sufficient metals in the global economy to get to that point of the circular economy that you were talking about. So, you know, do we get better at mining metals on land? You know, that's another possible solution, because at the moment the argument of the deep sea miners goes, well, the concentrations of metals are better in the ocean. There'd be fewer kind of, you know, effects on local communities. There'd be fewer potential human rights abuses linked to the mining of metals. So yeah, it's a very thorny issue, but there are environmental consequences, you know, to bring into that mix, which I'm sure you're in a better position than me to talk about.
And it's interesting, you know, you mentioned earlier that, you know, we're just not ready in many aspects of thinking about the equality and equity issues. But there's lots of things we're not ready for. There's lots we don't understand. And scientifically speaking, we're not ready. We don't understand what the impacts will be. You know, we have a good idea of what some of the negative impacts will be, but really fully understanding them, I think we're a way off. You know, the obvious one is damage to the deep sea ecosystem. So the reason that we're looking for pharmaceuticals, for example, in these deep sea ecosystems is because of this uniqueness, that they're endemic, we call it, and that means that there are not only unique species of organisms like deep sea sponges or corals, but in fact those different species might also have unique combinations of microorganisms that live within them. We call them their microbiome. So they house unique combinations of things like bacteria. And these are the bacteria that can produce the chemicals that we want for pharmaceuticals. So they produce the anti-cancer drugs, they produce the antibacterial drugs, the antimicrobials that we're really looking for because of the increased concern about antimicrobial resistance. So it isn't just a case of this is biodiversity for biodiversity's sake. You know, these metals that we're after, they will actually be fairly reactive. They could react with seawater and get released. That could cause poisoning of anything living around the mining site. There's noise pollution. There's pollution that simply comes from moving this stuff around, the shipping required to do this. So the knock-on effects really are very far-reaching and really haven't been properly understood. Like the main message that from my personal point of view, that I think needs to get across is this complexity. I keep coming back to the word complexity. And yes, there are scientific investigations going on, which, you know, absolutely, I'd rather that they are than they're not, absolutely. But it is an incredibly complex system, and trying to communicate that, I think, that, you know, to coin an overused phrase, these unknown unknowns even, that we can speculate on, we can try and model, we can try and test, but, you know, when you're dealing with so many interacting components of a system, when you don't understand the processes, you don't understand the rates of change that you might bring about. I suppose it's just, you know, that's the thing that concerns me, and I would like to get that concern across to people who need to hear it. And so I think it comes back to this idea of communicating complexity.
Yeah, and also communicating the more basic fact that we are down there and that this is happening. I mean, I think which kind of comes back to these cultural aspects of, you know, not treating the seabed as part of our domain. It's not, it's not like going and sort of, taking the top off of a mountain that you've been looking at every day of your life. These things happen in a concealed space.
I just think it's almost unimaginable now that, back in 1977, when they did first get video footage of the ecosystem growing on mid-ocean ridges, they didn't have a biologist on board. They really weren't expecting it. This was something completely that took them by surprise. And it was this assumption that you need to have photosynthesis in order to have an ecosystem. You have to somehow create energy. You have to somehow make organic matter that you can then use to live. And the way that we know about it, because the way that we see it every day, is photosynthesis by plants or algae. And then, they came across this ecosystem that was entirely separate. And there are bacteria that live there that will harness energy that doesn't require sunlight. It's chemosynthesis. It's a different way of doing things.
I guess so. That's just one kind of initial example of why interdisciplinarity, when approaching something like the seabed, is so important. Even within the sciences, the hard sciences, you need to have a physicist and a chemist and a biologist on an expedition like this to try and kind of get the whole picture. In your view, Kate, what's the value of going even beyond the sciences to the social sciences, political sciences, even humanities, in order to kind of come at an issue like the seabed and its future?
We can't just do science in isolation now, for many reasons. I guess the most important being that we need to actually have impact. We need to actually use our science to make things better, for want of a better way of putting it. So getting those key messages across to policymakers who can actually do something about it. But also, from a much more practical point of view, we need funding. We need to actually convince the funding organisations that what we're doing is important. And ultimately, a lot of the funding is based on taxpayers' money. So we need to be able to communicate to the public as well as to why this is important. It might be people from a fishing community, for example, understanding the impact of coastal sediments on the ecosystem that fundamentally supports the fish that they catch. It might be the people who want their iPad and so need to have the green technology to power their iPad. So I think understanding the differences in the points of view of the different stakeholders involved, I think, is really critical.
So it's not just about communicating the science itself, it's about communicating the fact that the deep sea is a site with which we're involved and that we're going to become more involved in.
Absolutely, and communicating it in a meaningful way to the different stakeholders involved.
So, Kate, what would be your message to policymakers in relation to the seabed?
There are so many things to talk about. There are so many messages, but I think to try and summarize it, I suppose, the oceans are inherent in, and I think the three key scientific challenges going forward, which are climate change, loss of biodiversity, and society. I think it really comes down to those three things. And not only do the oceans play a key role, but the seafloor is a primary factor in all of them. So I think the message is the seafloor matters to us. How about you?
Yeah, I think I'd say that we need to invest more, both financially, but just in terms of kind of thinking about a relationship with the seabed that we've kind of developed and initiated without necessarily kind of realizing as global citizens that we've done it, that we are kind of involved in this area, even if we sometimes think of it as alien, and that we need to be more conscious of that involvement than we currently are. And I think the other thing is that any solution or plan as to the future of the seabed needs to be global. I mean, in the more literal sense that, it needs to involve people from all nations, including landlocked nations. But also in the more sort of metaphorical sense that it has to be global, it has to come at things from lots of different perspectives. I mean, scientific perspectives, economic perspectives. It has to balance out the different strategic goals of the UN, like eliminating poverty, but at the same time taking climate action. And sometimes those goals may conflict, but we need to think about how they do so in relation to the seabed and find a workable solution. I think we need to be conscious of its various meanings and bring as many people into the conversation as possible when we think about its future.